Hi everyone, today we will start a new subtopic, simultaneous equations. Previously, we have learned three ways of solving simultaneous equations, that is, elimination method, substitution method, and graphical method. In lower form, we have learned how to solve a pair of simultaneous equations where both are linear. And in chapter 3.1, we have learned how to solve system of linear equations in three variables. The table over here shows us the summary of solutions to simultaneous equation in two variables and three variables. For simultaneous equations that involve two variables, when both lines are intersecting, there will be only one solution. When both lines are overlapping, we will get infinite solutions. Last but not least, when both lines are parallel, there will be no solution. For system of linear equations in three variables, when the planes intersect at only one point, we will have one solution. When the planes intersect along a straight line, we will have infinite solution. And when the planes do not intersect at any point, there will be no solution. Today, in this section, we shall learn how to solve a pair of simultaneous equations in which one is linear while the other is non-linear. We would normally use substitution method to solve equations like this. Let's look at the example. Example 3.2.1. Solve the simultaneous equations x plus 2y equal to 5 and x squared minus 3y plus x is equal to 9. Hence, state the coordinates of the point of intersections of the line x plus 2y is equal to 5 and the curve x squared minus 3y plus x is equal to 9. So first we need to solve for the simultaneous equations. Then we need to state the coordinates of the point of intersection. We are given two equations. The first equation, x plus 2y is equal to 5. We let it be equation 1. And the second equation, x squared minus 3y plus x is equal to 9. We let it be equation number 2. Since we are using substitution method to solve for these simultaneous equations, we need to make one of the variable our subject. For this case, I will make the x variable in the equation 1 our subject. From equation number 1, x is equal to 5 minus 2y. We let it be equation number 3. Keep in mind, equation number 3 and equation number 1, they are the same equation. Then, we substitute equation number 3 into equation number 2. 5 minus 2y squared minus 3y plus 5 minus 2y is equal to 9. We expand the bracket. 25 minus 20y plus 4y squared minus 3y plus 5 minus 2y, and we bring the 9 to the left side, become minus 9 is equal to 0. Then we simplify the equation. 4y squared minus 20y minus 3y minus 2y. We have minus 25y. 25 plus 5 minus 9. We have plus 21. And the equation is equal to 0. This is a quadratic equation, hence we need to factorize it. 4 can be 1 times 4 or 2 times 2. 21 can be 1 times 21 or 3 times 7. We need to get a negative 25. There are many combinations, hence we need to do trial and error. Let's try 1 times 4 and 1 times 21. 4y and y, 21 and 1. Here we will get a 4y, and here we will get a 21y. In order to get negative 25, we need to minus 4y minus 21y. Hence, we put a negative here and a negative here. And we need to check negative and a negative, we will get a positive. Therefore, this is the combination that we are looking for. We let the equation equals to 0. In order for the equation to become 0, it's either 4y minus 21 is equal to 0 or y minus 1 is equal to 0. For the case 4y minus 21 is equal to 0, 4y is equal to 21, y is equal to 21 over 4. And for the case y minus 1 is equal to 0, y is equal to 1. After we found our y values, we need to find our x values as well. We substitute the y value into either equation to get our x. In this case, I will substitute the y values into equation number 3 to obtain the x values since we already make x our subject in equation 3. Substitute y equals to 21 over 4 into equation 3. X is equal to 5 minus 2 multiplied with 21 over 4. We simplify the equation. X is equal to 5 minus 21 over 2, which is equal to 10 minus 21 over 2, and we get negative 11 over 2. Hence, the first coordinate of the point of intersection between the line and the curve is negative 11 over 2, 21 over 4. Then we substitute y equals to 1 into equation 3. X is equal to 5 minus 2 times 1. We get 3. The second coordinates of point of intersection is 3, 1. Now let's look at example 3.2.2. Solve the equations and sketch the graphs. We are given two equations. The first equation, xy is equal to 12, equation number 1. And the second equation, 2y is equal to 3x minus 6. We let it be equation number 2. The same thing, since we will be using substitution method, we need to make one of the variable our subject. For this example, I will make the y variable in equation 2 our subject. From equation 2, y is equal to 3x minus 6 over 2. We let it be equation 3. Keep in mind, equation 3 and equation 2, they are the same. Then we can proceed from here. We substitute equation 3 into equation 1. X multiplied with 3x minus 6 over 2 is equal to 12. We expand the bracket and multiply the whole equation by 2. We will obtain 3x squared minus 6x is equal to 24. We rearrange the equation into general form. 3x squared minus 6x minus 24 is equal to 0. Then we need to factorize this quadratic equation. 3, there's only one combination, 1 times 3. 24, it can be 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Therefore, for 3x squared, we will have 3x and x. And we need to find the combination that can give us negative 6x. 1 times 24 will definitely never give us a negative 6x. If we put a 2 here and we put a 12 here, we'll obtain a 2x and 36x. 2 and 36 will also never give us a 6. Let's try exchange the position of 2 and 12. Here we will get a 12x. And here we will get a 6x. This combination will give us a negative 6x by putting negative at the 12x and positive at 6x. Minus 12x plus 6x. And always we need to check negative and positive, we will get a negative. Hence, this is the combination we need. In order for the equation to be 0, 3x minus 12 is equal to 0, or x plus 2 is equal to 0. For 3x minus 12 is equal to 0, 3x is equal to 12, x is equal to 12 divided by 3, that is 4. And for the case x plus 2 is equal to 0, x is equal to negative 2. After we found our x coordinates, let's substitute them into either equations to get our y coordinates. Since we already make y our subject in equation 3, therefore I will substitute the x values into equation 3 to get our y values. Substitute x is equal to 4 into equation 3. Y is equal to 3 multiplied by 4 minus 6 divided by 2, which is 12 minus 6 over 2, 6 over 2. Hence, y is equal to 3. The first coordinates of point of intersection between the straight line and the curve is 4, 3. Then we substitute x is equal to negative 2 into equation 3. Y is equal to 3 multiplied with negative 2 minus 6 over 2. We get negative 6 minus 6 over 2, which is negative 12 over 2, and our y is negative 6. Hence, the second coordinates for the point of intersection is negative 2, negative 6. After that, we still need to sketch for our graphs. First, we draw the x-axis and the y-axis. The first equation is xy is equal to 12. We bring x to the other side. We get y is equal to 12 over x. This is a reciprocal graph. And for the second equation, we already obtained y is equal to 3x minus 6 over 2. We further simplify it. We will get y is equal to 3 over 2x minus 3. From this equation, we can see that we have a positive gradient and our y-intercept is negative 3. Hence, the graph should look like this. The equation is y is equal to 3 over 2x minus 3. And for the curve, y is equal to 12 over x. And our point of intersection are 4, 3, and also negative 2, negative 6.